rapid prototype, the Lego model that you should have turned in from homework 3, uploaded to D2L already. So you're going to actually go and rapid prototype this thing. But you're not going to do it. Since there's 17 of us, I'm going to give him all the files, and he's going to print it all on one tray. So it's not one by one. It's more efficient. So what you need to do is upload what kind of file will that 3D rapid prototyper take? STL. So you need to upload an STL file to D2L by homework 4. When's homework 4 due? By Tuesday of next week. Tuesday of next week. You probably already have it, so if you have it, just upload it. As soon as I get all of them, I will send them on to Kai and have him print them. And remember, it must be half scale, so they're going to end up being about this big. Okay? Don't put a monster in there, because it'll cost us a bunch of money. You'll lose points for that. And then style points for putting your initials or your name or something on there. Okay, any questions on that one? That one should be pretty easy.
So is that homework 6?
That's homework 4. Homework 4. Okay, homework 5 is to create a part using a traced image. Okay, and we're going to go over that in this segment right here. So you'll learn how to do that right now. And then the homework for that will be to create your own part. And the style points will be to make it something cool and neat that's personalized to you. There's also style points awarded for creating a part that will use both the that will use the raster function from the laser cutter training you heard today. So you can get some extra style points for using a raster somewhere in the part that you create. So you'll be making a SolidWorks part for me that will be for homework 5. You'll be making a SolidWorks part for me that you will upload to D2L, and that's due tomorrow at 10 on D2L. And remember, so that I know how to grade you, you should be using the file name convention first name _ last name .sldprt when you upload. And then
any information about what the file contains?
No. It'll be uploaded into the correct folder for homework 5, and then it's just your names, and I'll know what that is. Okay. Then homework 6 is to actually take that part that you created in SolidWorks and go laser cut it. And that's why I handed you out material. So that's your final material. A couple of warnings. That's the only material I'm going to give you. So if you screw up, you're either going to be deducted points or you have to go find your own material and redo it. Okay? So with that in mind, what you might want to do is practice on either some of the scrap material that's under the laser cutters over at ITL, or even just a piece of paper taped down into the laser cutter, just to see if it kind of runs around the part and does what you're expecting it to do before you use your final piece. Okay, and then when you use your final piece, you can adjust the power and speed settings to go ahead and cut through it. So, and you should have learned that today. So that is homework 6, actually physically cutting that part out and then turning it in. And style points are rewarded for how cool it is. Use of the raster function, maybe you want to do some other cool stuff. Maybe you want to do something using, I don't know, crayons or paints or something. Or anything else you can think of. Be creative. And then you'll actually turn in the physical piece to me. If you want that piece after I'm done grading it, you can have it back. But I just need it for a day or so to grade it. That one is due next Friday. Not this Friday, but next Friday. And that gives you some time to get over to the ITL and get all that done. Okay? Although I would recommend to you that you start doing these homeworks as soon as possible, because as I told you, this class starts off slow, but we are going to kick it into overdrive here very, very quickly. You will be making parts and making solid models quickly. So the more you can do as it's assigned, the better. So don't get lulled into this sense of security. I'm going to start hammering you with assignments and stuff to do. All right. Any questions about homework? I need you to do the assemblies tutorial within SolidWorks. Also, the drill press video from YouTube, machine shop videos, and the drilling and tapping holes video. Okay, make sure you do those because we're going to be assigning you things off of those. So make sure you're keeping current. Questions there?
When you assign us the tutorials, do you want us to frame the end product of the tutorial at all?
Well, like I said earlier in the course, I think it was yesterday, you need to be ready at any given time. Some things may be graded, some things may not be graded. But you need to be ready to hand to me a digital file somehow, either on a thumb drive or uploaded to D2L from the cloud, something. So I'm not telling you. I'm not going to let you know. All right. Okay. In order to help you with homeworks 5 and 6, we're going to go into creating parts from drawings or from pictures, from picture files. But just before we do that, Kai reminded me of the line settings for the laser cutter. So I wanted to show you that real quickly. So I'm just going to open up the drawing file that I created for the little box that you're going to be assigned later that houses the microcontroller and the power boards for the controls lab. I'm just going to pull up that drawing and show you what he meant by the line thickness style. And I'm glad he brought that up, but I think you're safe with the SolidWorks defaults. But I wanted to show you where those are. So here's the drawing of this box, the sheet metal box, and we'll be going into this, I believe, Friday. We'll be going into sheet metal Friday. But if I zoom in on this and I click this line, this little bar opens up for me. And if you look at line thickness, I believe this is what he was talking about when he called it hairline. If you make this line thickness a lot bigger, the laser cutter is not going to really recognize it properly. So you want it to be as small as possible. It looks to me like SolidWorks defaults as the smallest possible line. So I think you're okay.
And are those options only available in SolidWorks drawings or parts as well?
I believe it's only going to be in drawings, and you can do it line by line here, or you should be able to go to Tools, Options, and have a document property with line thicknesses in there. And I believe that's going to be in drawings. I've actually never looked that up because it's never become a problem. So you can look for it in here. I don't think it's going to be an issue because I think it defaults properly, and even if it doesn't default properly, Kai showed you how to fix that within CorelDRAW. So, but I've never had a student ever have a problem with that from importing from SolidWorks. He must have, but it must have been because those students were playing with their line thicknesses. Maybe to make it look better on their drawing or easier to see. Okay, so I wanted to tell you that. And then I wanted to reiterate, this is a common theme with aerospace students that we see. You need to know when to use the laser cutter and when not to use the laser cutter. Remember, the laser cutter cuts by melting. So at the top of your part, it's going to melt more than at the bottom of your part as the laser comes down in. So you're going to get this very slight, and it's on the order of thousandths of an inch, trapezoidal effect on the edges. And on those edges, you're going to be able to feel a surface roughness, whereas a machined edge will feel very smooth. Well, some of your parts that you design may need to fit within less than thousandths of an inch. So at that point, those rough edges aren't going to work for you. The other issue is acrylic, which is mostly what you use, and sometimes ABS, is a thermoplastic and it has mechanical properties. If you machine a part that you expect to have some sort of structural integrity, you need to be careful because acrylic tends to shear and crack very easily. It's very brittle because it's hard. So don't trust these parts to be structural components unless you've done a structural analysis on that component and you've determined that that material property can handle the loads that you're going to subject it to. So laser cutters are cool and they cut things out, but be careful where you use the pieces that you cut out. Okay. All right. I'm gonna have you. I've assigned you a laser cut part, and you may want to do cool pictures. So I need to show you how to import pictures and trace them. First thing is SolidWorks has not only for drawings, but for or not only for sketching pictures, but for all kinds of other issues. It has these things called add-ins, so it doesn't give you the entire package all at once. It's already big enough to load up into RAM to start with. But it has these add-ins. So if you go to Tools, Add-ins, you can see a list of some of the add-ins that are available for SolidWorks if the computer will cooperate. Here it is. So you can see some of the add-ins that they don't throw in for you right away. One of those add-ins is Auto Trace. So I'm going to put that one in. And then the other thing I'm going to put in is Photo View. I think I might have told you yesterday that our educational version doesn't have Real View, but it may have it. I haven't tried it. Let's try it here as an add-in and hit OK. And we might go back and try that and see if that Real View shows up for us. Let's give it a second. I think it's thinking. It is thinking. Okay. Now you may want to follow along with me, but you might want to open a web browser because you're not going to have a picture to follow along with me on, but you might want to get Google ready so that you can go jam yourself a picture real quick. All right, so
Will it matter what kind of file type we use?
I don't think so. Anything that's kind of a standard picture file like a bitmap or a JPEG or a TIFF, I think will all be okay. So I'm going to open a new part because we're going to create a part, and I'm going to open a sketch, and then I'm going to import a picture onto there. So let me go to Sketch, New Sketch, just pick any old plane. All right, here's where we do the picture. So I'm going to go to Tools, Sketch Tools, wake up computer, wake up, come on, and then go down this menu a little bit and go to Sketch Picture. This is terrible. Let's do a little focusing here. There we go. Okay, Sketch Picture. And then it's going to want me to go find a picture. This is where you can go to Google and find yourself a picture. I'm going to use this one. You don't have to go ahead and find yourself one, but you don't have to hurry because you could just kind of watch what I'm doing. I'm actually going to open up two different pictures. So, all right, so the first one I'm going to pick is this one. You might recognize this, especially since we're closing in on lunchtime. All right, so I enter the picture, and it gives me a couple of options here. It gives me this little scale bar, and I can scale this thing or I can rotate this thing. It also gives me a horizontal and vertical dimension. This particular picture is square, and it recognized that. I'm going to go ahead and I gave you guys a 6x6 piece, right? So just for fun, I'm going to put this down to 4 inches just to make sure it'll fit. And I'm going to select accept that. Okay, so now I've got a picture within SolidWorks. The problem is SolidWorks only recognizes this as a picture. It's not sketch geometry. It doesn't exist for purposes of making a part. So we need to sketch this little M here. All right, now I added in the auto trace feature, and I want to show you how to use that, but immediately following me showing you how to use that, I want you to forget it because it never works. It's really terrible, but I want to show it to you anyway just for fun, and I wanted to show you those add-ins as well. So if I go to, let's see, sketch, let's see. Oh, actually, I messed this up. I'm sorry. I'm going to delete that, and I'm going to re-import it. Sketch tools, sketch picture. I'm going to drop it in 4 inches. All right, here is where, so if I did not do the add-in, I would not have seen this little arrow, which is the next menu. You need to be careful because that's really, it's so hidden on some of the menus, you wouldn't even think to push that button. It's so small. But it gives you other options, all right? And in this case, it gives me the auto trace option. So I can have SolidWorks try and figure out this M, all right? And so what you have to do is select a portion of the picture and see if SolidWorks can recognize the edges. So I'm going to select this little lasso tool so it allows me to freehand, and I'm going to click, hold, and drag and try and reduce the boundary area with which SolidWorks has to think about what it's going to recognize. So, and if I wanted to make it even better, I could go up inside here. That just helps SolidWorks exclude a whole bunch of pixels out of that picture. So I'm going to drag this over, and then I'm going to make sure that I drag it over and make it coincident with that point. Okay, and then it's going to say, okay, I'm going to exclude the rest of that picture and only look within this boundary, and that's good. And then you can play around with these tolerances on brightness and contrast, and that might help SolidWorks get a better approximation for this thing. Now I'm going to go ahead and hit OK, accept it, and you'll see that SolidWorks tries to figure out.
Can you do this multiple times to get like a full image that has multiple different colors?
Yes, you can do multiple selections, and it didn't even do it for me. I'm going to try that one more time. But if I don't get this to work, I'm going to move on because it does such terrible approximations. I don't want you guys to get the impression that this is something super important to do. I'm going to show you the way to really do it. Okay, so let's try that again. Oh, I didn't hit begin trace. I forgot to hit begin trace. Sorry. So hit begin trace, and look what it did. It did give me sketch geometry. Okay, this is actual sketch geometry, and it's a closed boundary. I could extrude this. However, I'd probably have to delete this little part because you can't extrude this. It's not a closed boundary. And I think it picked it up because I wasn't careful about how I drew my boundary around the M. So you'd have to delete those as sketch geometry. But look at how bad that is. I mean, that's if we're going to steal this company's logo, at least we could do a nice job with it, right? So I'm going to go ahead and just cancel this out. I don't want it. All right, now I'm going to show you how to do a better job. All right, so you're going to trace this picture yourself. Now, it'll be pretty easy to do so with some of the pieces. So, for example, these pieces down here look pretty horizontal, right? So I could just use my nice line geometry, right? And I could do one over here, right? And one over here. And I can even make that, did you see how SolidWorks asked me if I wanted to be collinear with that other line? So you can make it collinear, that makes it a pretty good sketch. Now, our problem is these guys. That's not going to fit a circle or a polygon or a rectangle or any of that jazz. It's probably not even going to fit an arc, a predetermined polynomial arc. But what it will do is fit a spline. So I'm going to show you splines. So click the spline tool. Now with the spline tool, you can click a multitude of points and then play with those points. I'm going to give you some hints though. All right. Splines work best if you pick arcs or semi-arcs that are kind of moving in one direction. If I was to use a math analogy, remember back from calculus and polynomials, you've got inflection points when your slope is increasing or decreasing on your second derivative, right? So on your first derivative, we've got positive and negative slopes. On your second derivative, we've got concavity that changes. So splines work best if you stay with just one increasing, don't move between the positive and the negative derivative, and don't move between concavities. So in this case, I could technically make a spline that does this whole arc and this arc. And I might even be able to get one that does both. But it becomes significantly more difficult as you do that. So the smarter way to do it is to create a spline that only goes up to this inflection point. All right. So, and it's better if you use a smaller amount of points for your spline. So you can click multiple points for your spline. That first one I'm going to show you, I'll do one on this side and one on this side, and I'll show you what I mean. So if I wanted to do this the way I would do it, I would click one point here and one point kind of at the apex of the M. And then I would hit escape. And there's a spline. Okay, let's try it on the other side by hitting one point here and maybe one point here and maybe one point here. Okay, and there's another spline. Now once you have those splines in, you can adjust them. So if I re-click that spline, I get some tools here, and I'll show you those. First of all, I have the endpoints of that spline, and I can move them around, but I'm pretty happy with those endpoints. I want this endpoint coincident with this little line, and I want this endpoint coincident with the vertex of this parabola here, or whatever shape this is. What if they hired a math guy to make their M? Anyway, you also get 4 other points with which to adjust this spline. These points here will adjust a length of a spline. So if I click this point and I pull, I can adjust this length. And look at that. I already have a pretty darn good approximation to that M. Okay? And I can do the same over here with this one. I can kind of twist this around. Okay? Now, then you've got these diamonds, and you can pull those, and they do a little bit more of a fine adjustment up and down. Okay, they don't go left and right. They're adjusting the angle between this slope of this tangent line and that end point of my spline. Okay, so that gives you kind of a finer adjustment there. I can look here, and I can adjust this one as well. And that's pretty good. Okay. Now if I go back to this one, that one's cool too. But you'll notice since I clicked 3 points, I got an extra set of adjustment points. And the problem with that is that's cool, but look how I make changes to one here and I get changes all over the place. Okay, so the more points you put in, it becomes increasingly difficult to adjust just one component at a time. It does work. It's not too bad, but it becomes a little more difficult. But that one worked out okay. That's not too bad, right? All right, just for fun, I'm going to complete this quickly because I have a couple of other things I want to show you. So I'm going to cheat and just put lines in. So it'll be really terrible, I know. Ronald would be very upset with me. You finish the sketch. Make sure that all your boundaries are included, are closed. So otherwise you won't be able to extrude a 3D component. You can click your image and you can suppress the image. And then the image just kind of goes to the background. If you look under the sketch, that sketch picture is buried within the sketch if you ever need it again. Okay? And then you can go ahead and go to features and extrude your boss base. It's upset with me because I did not have the sketch selected to extrude, so it doesn't know what I want to extrude. So I'm going to hit X, I'm going to go to my sketch, and then I'm going to extrude it. And I can go however much I want. Let's say we're going to cut it out of our plastic, so we'll do a 1/4 inch thick. One interesting engineering note, you guys might, just for fun, take your plastic and measure it with calipers before you go cut it, or maybe save some scrap and measure it with calipers. You're going to notice that 1/4 inch acrylic isn't really a 1/4 inch. Okay? It's significantly different. I think it's something like 12 or 15 or 16 thousandths different. That's a good lesson to learn. In fact, I'd like you guys to do that. I'm not going to assign it, but you should go do it. Next time you're in the shop, grab a pair of calipers and measure your plastic. Maybe peel back the little protective paper that's on the plastic and then measure it. Because material comes in what we call nominal sizes, which is approximately a 1/4 inch. It's close, but it's not exact. And you guys are going to be pretty good engineers once you leave CU. You're going to be doing some things that are more accurate than the material that comes in. So you need to understand that materials come in nominal sizes, and you either need to find out the nominal size, or you need to and enter that into your CAD models, or you need to allow for a tolerance that's big enough to accept those nominal deviations in those nominal sizes. You have any questions on that? Or a third thing you could do is understand that it's a nominal size. It's probably going to be in plastic. It's usually under, so a 1/4 inch piece might come in 0.238 instead of 0.25, and you can design your part to be well under that so that you have to machine that part. Okay. Now I've got another consideration for an engineer. This is why they pay you guys so much. If you machine acrylic or a plastic, you will cloud that surface. So right now your acrylic is see-through. If you machine it, it will become more opaque where you machined it. Or even if you laser cut it, it will become more opaque. So keep that in mind. If you're going to machine the face and you expected in your assembly final product that be a see-through piece, then you can't machine it. It won't be see-through anymore. Or you're going to have to spec out an intensive polishing process, which is going to cost time and money. So be aware of that. All right, I'm going to close this. And just to illustrate the point a little more, I'm going to open up a part, start a sketch, and I'm going to bring in a different, so sketch tools, sketch picture. I'm going to bring in a more appropriate picture for us. Notice that this isn't a square part, so the scaling and aspect ratio are going to be different. I definitely want this to fit on a 6x6. All right, and if I wanted to, I could even sketch myself a 6x6 rectangle just to be absolutely sure that I like how my little Ralphie's going to fit in there. So you notice I set one dimension of my Ralphie in as 6, but that's the entire picture, not just the Ralphie. So I just wanted to make sure I like that or not. I like this. I think this is pretty nice. So I'm going to go ahead and delete this geometry. Why am I going to delete this geometry? This rectangle I made. Why am I deleting that? No? I'm trying to make a Ralphie in my plastic. If I have this and I draw this Ralphie, will it extrude? No, it would probably guess that I wanted to extrude this square and then maybe make a cut of the Ralphie out. So I don't want to do that. So I don't want to confuse the extrusion with the outer boundaries of my plastic. So I'm going to delete that. Alright, so I've got my picture, and now I need to trace it, and I'm going to do it with splines. Again, remember, you want to keep your splines as simple as possible. So for example, I might do Ralphie's back in one spline with 2 points and then adjust it. I could try and do his, or actually our Ralphie's a girl. Don't know if you knew that. But they couldn't. They wouldn't be able to handle a boy running across the field. He would trample everyone. So I could try and do the 2 humps of the back here, but it's going to get a little more complicated for me. So I would rather do it just with one single spline. So keep your concavities and keep your inflection points as one spline. Okay. Another thing that I may have an issue with is, let's say I want to cut the Ralphie out, but let's say I wanted to raster the CU rather than cut it all the way out. Well, you're going to have to make this a different set of geometry, right? And then maybe do a cut, but not all the way through, and maybe just a few thousandths. Corel Draw over in the ITL may also, if you just sketch this internal boundary, as long as you close it up, it'll probably recognize that area as something you can raster. You'll have to find that out on your own, so play with that. If you were doing something that's like a CU, you don't have to do that. Again, this homework is totally creative. Do something that you want to do. Maybe you can give your mom a late Mother's Day present or something like that. Or maybe you want something to hang in your car or on the wall or something. So you come up with something creative, something fun. All right. Do we have questions here?
Not specifically on this, but because say that you do have these 3 different colors and you want to make them at different sizes, how would you go about doing that?
Different colors, different sizes. I don't understand the question completely.
So, say that you want to raster the CU and the buffalo horn at different sizes. Would that be possible?
What do you mean sizes?
Depth.
You mean depths?
Yeah.
It would be possible. And so what you would have to do is you would have to draw this in. You're going to draw the different pieces anyway. So let's say the CU and the horn. Say you wanted the horn to be deeper. Okay, you'd have to draw the CU in, which you're going to do, and what would you use to draw the CU in?
Since it's mostly straight pieces, probably just lines.
Just use lines, right? And then you might use splines on the horn. As long as you make them distinct, when you go over to Corel Draw, you will be able to just grab that one piece. What you'll do is you'll adjust your speed and power settings on the laser. Or you can keep the same settings and rerun the path multiple times.
So you just change the path that it's run.
It's the same path it's going to run. It's just you're either rerunning it a second time so the laser hits it again, or you're adjusting the power settings on the laser for, let's say, the horn. Let's say you slow the laser down by 10%, and that will, or 15%, and that will give more exposure time with the laser to the plastic, and then maybe you up the power by 10% as well. So the laser is more powerful and it's going slower. You should get a deeper cut. Or you can run over it multiple times. Yeah.
Do we need to extrude it when we're going to be putting in Corel Draw, or is that just going to use Corel Draw? So are we giving Corel Draw a 3D drawing or a 2D drawing?
You want to give Corel Draw a 2D drawing. It's going to be a DXF file.
Okay.
Now, I want you to make a SolidWorks part file for me. So you will have to extrude this for me. In order to get it over to Corel Draw, you are going to have to make a drawing of this thing, save it as a DXF, and then take it to Corel Draw. So will you remind me to tell you about, to revisit that in just a second? Remind me about that. Any other questions on this buffalo? All right. The buffalo doesn't make a lot of sense for what I'm going to tell you next because it doesn't have symmetry in any axis. I'm going to show you, I'm going to go back to my McDonald's. And this is where I want you to remind me of that question once I'm done. I'm going to go to a new part. Sketch. I want my McDonald's again. Not tools option, sketch tools. Pay attention. Sketch tools. Okay, I'll make this 4x4. And then I'm going to trace it. Now, as much as possible, what you should do, well, let's put the lines in first. That's the easy part. So again, make sure, since this does have symmetry in the vertical axis, I want to try and keep this as symmetrical as possible. All right. So if you were to use this side over here, make sure that you hover over this and get it to be collinear. Now, whenever you do have something that has symmetry, because spline tools, if you look at the spline tool, notice that I am going to adjust this by clicking and dragging. Clicking and dragging is not going to be something I can replicate exactly. So if I tried to do this same spline over here, there is no way I can make those two endpoints collinear, but there's no way I'm going to click and drag this thing the exact same way as the spline that I just did. So when you do have symmetry, consider using that symmetry to your advantage. So instead of doing a spline on this side, I'm going to do a spline on this side. I'm going to make this collinear there and adjust my Mickey D. I'll make a spline here and adjust my Mickey. Okay, I'll make a spline here. Make a Mickey. Okay, now I want to mirror, I'm going to use the mirror function. And if I use that mirror function, all these click and drags that I just did, I can exactly duplicate on the other side. So my M won't look kind of just barely off. It'll look exactly right, symmetrically in the vertical axis. Got some problems going on right now that are going to prevent me from doing that. First of all, I can't have this geometry in here. So I've got to delete this stuff. And I've got another problem. What's my other problem? Anybody see a problem? I have no axis to flip it. That's one. There's another one.
The line at the bottom of the middle is.
Yeah, this line at the bottom in the middle is too long, right? So if I did have that vertical axis, it should go kind of to the midpoint of that line. And in order to properly mirror it, I can't mirror a line onto itself. SolidWorks will freak out. So I've got to adjust this line such that the end point is vertical with this point. So I could do that. I could adjust it, or I could add a relation, right? Oh, starting to understand those relations a little bit better. Okay, so that looks good there. Now, I do need some sort of axis there. So you could draw in a line. The problem is if you draw in that line, let's try putting in a center line and see if it jives with this. I'm not sure it's going to let us mirror a real line onto itself because it's not going to understand what to do with those two lines. You can't have two lines on top of each other. So I put this different kind of line, this center line in. Going to discuss tomorrow reference geometry. You could also put in a reference axis, which definitely is not sketch geometry, and therefore it definitely will not mirror onto itself. But let's just give this a shot. All right, so we're going to use the mirror entities function right here in your sketch tools. Entities to mirror, you've got to select them. And then what do I mirror about? I need an axis. There it is. And you can see the preview. It did it. I accept it. And now I'm a happy camper. Look at all the relations it put in there from the mirror. It's got a bunch of mirror relations, symmetric relations. So if you go to your display delete, now you have all these symmetry relations. But that's okay. All right, so there's our M. I'm going to delete this little axis. And now I've got all these closed boundaries. I can exit the sketch. I can right click on my drawing and suppress it so it's gone. And I can go to my sketch and extrude my part. There's my M, looks really nice. All right, back to your question. How do we get this over to CorelDRAW? CorelDRAW needs a DXF file. So you're going to have to make a drawing of this file. We'll go into drawings in another lecture in more detail. But for right now, go to File, Make Drawing from Part. I guess we got to save this file. Fine. I'll go ahead and pick the default drawing file, because in this case I do not want a title block, right? Because I'm just going over to CorelDRAW. All I want is the M. So I don't want a title block. I'm going to hit custom sheet size. If I hit custom sheet size, since it's custom, it will not put in a title block. All right? Unless you selected your template, which you should have uploaded to D2L, right? So now I've got a blank sheet, which is what I wanted. I didn't want the title block just for going over to CorelDRAW. I'm going to go ahead and pick this top view, drop them in there. Okay. One thing you may want to do is check the scale. So you may want to hit Evaluate and Measure. So under this Evaluate toolbar in your Command Manager, you may want to measure from point to point, my distance is 1.87 here. So that's a lot smaller than my 6x6. If I want that bigger, then I can click this drawing view and I should be able to scale it. Use a custom scale, and I can play around with my scale until I like it. I could definitely go 1 to 2, right? I can definitely go bigger because I have more space. But you can play with that scale until you get it to the size you want before you go into Corel Draw. Now in Corel Draw, I believe that you can also scale. So you could scale here or you could scale there. It's up to you. The more important part is that when you're ready to save this so that you can get it into a file type that Corel Draw can import, go to File, Save As, go to your Save As type, and instead of a SolidWorks drawing file, we can make this a DXF file. DXF stands for Direct Exchange Format, and it's the most portable type of drawing file across CAD packages. AutoCAD understands it. Corel drawing programs understand it. Almost every CAD program and a lot of other programs understand DXF file formats. So that's kind of an important one to know just as an engineer. Save it as a .dxf, and now you can go over to Corel over in the ITL and start playing with it. Any other questions? Does anyone have any questions on homeworks that are assigned or when they're due or anything else?
So if this homework is due tomorrow, so we're making a part, so a 3D part.
Yep.
Do you want the image to be copied or you just want the part?
Just want the part. First name underscore last name dot SLDPRT uploaded to D2L. Style it up if you want to. The part. Other questions? Have a nice day.